Hello, in this video we'll take a look at A-level physics, specifically for EDEXCEL. We'll take a look at the polarization of transverse waves in this video, and more importantly we'll consider the context of Polaroid filters. So we know that transverse waves such as light can undergo the process of polarization. To understand polarization, plane polarization has to be considered first, and by definition plane polarization is the restriction of electromagnetic vibrations, especially light, to one direction. So when light is emitted by a given source, it is unpolarized, meaning that it vibrates in many different planes. Converting unpolarized light into polarized light is known as polarization, and a device which allows light to be polarized is known as a polarizer. Now, a polarizer has a Polaroid sheet which is composed of molecules arranged in columns parallel to each other, and the gaps between two adjacent columns allow for light of a specific orientation to be transmitted. Light waves, and more specifically if their electric fields are of a different orientation to the filter's transmission axis, then light is not able to pass through and is therefore absorbed by the polarizer, and in this way unpolarized light can become polarized. And I'll explain more about this in the next slide. So, as the oscillating wave propagates towards a Polaroid filter, the electric field that is vibrating parallel to the transmission axis of the filter is actually transmitted. Electric fields vibrating in different directions to the transmission axis are absorbed by the filter, so this would result in polarized light. Now once again I'll just restate this. So we have the following diagram which shows unpolarized light with its electric fields vibrating in many planes, and the vertical electric field vector is parallel to the transmission axis of the polarizer. Light that is of the same orientation to this axis is able to pass through, and therefore this filter would provide polarized light. Now, taking a look at a Polaroid sheet on a molecular level, we know that it consists of molecules that are aligned next to each other. So, taking a look at the first diagram, we have a following wave oscillating along the y-axis with its electric field, which is parallel to these molecules. And as the wave interacts with these molecules, the energy is transferred from the wave and is absorbed by the molecules. Therefore, no wave is able to actually pass through. However, in the second diagram, we have the following wave that is oscillating along the z-axis with its electric field, which is perpendicular to these molecules. So no energy is transferred to these molecules and the wave is able to pass through without being absorbed. And what we would end up with is an electromagnetic wave which emerges from the polarizing film, which is linearly polarized. So all of its electric field vectors are basically aligned with the transmission axis of the polarizing film. Thank you all for watching. I hope this video has been clear and made anything that was difficult to understand regarding Polaroid filters just easier to understand. Thank you all for watching, and goodbye.